Who's ready to write some polynomials in standard form given roots? I know that you are, so let's get going. Again, we're going to be writing a polynomial in standard form giving roots from a polynomial, which remember, roots are the same thing as x-intercepts, zeros, or solutions. So these are the solutions or the zeros or the roots of the polynomial. And basically, we're going to be working backward, kind of like you saw in the Prezi video in example 1. But this time, we have some imaginary roots in the mix. Alright, now before we get going on these lovely 2 example problems, we need to talk about something that is going to pop up in the problem, and that is this I squared over here. Okay, eventually when we are multiplying and distributing our two factors together when we're in factored form, an I squared is bound to pop up, which I squared is equal to -1. Now, let's talk about why I squared is equal to -1, because I know that you're dying to know why. So I have a little demonstration here to show why I squared is equal to -1. Okay, this doesn't really pertain to this problem specifically, but it will explain why I squared is equal to -1. So let's talk about it. Root 4 times root 4. Now when we square things, that's like multiplying something to itself, right? So root 4 squared is like root 4 times root 4. Root 9 squared is like root 9 times root 9. And root 16 squared is like root 16 times root 16. So I'm going to apply the same concepts of squaring real numbers to squaring imaginary numbers. So the square root of 4 we know is 2. And the square root of 4 is 2. And 2 times 2 gives us 4. Okay? Same thing here. Square root of 9 is 3. The square root of 9 is 3. And 3 times 3 is 9. Alright guys, square root of 16 is 4. Square root of 16 is 4. And 4 times 4 is 16. Okay, so you're probably noticing a pattern, you guys. If you notice here, the thing that we're squaring underneath the radical is what we end up getting. Do you guys see that? Every single time, whatever we had in our square root ended up being what we had in the very end. So the number under the radical equals the number out here. So if we apply that same principle to I squared, which I squared is I times I, and we know I to be the square root of -1. So I is the square root of -1. So root -1 times root -1 is going to equal -1. Okay, and another explanation of this, you guys, when we square something, that undoes a square root because they're inverses of each other. Like if I square a root 4, the square undoes the radical. I said it right that time. Ha. Alright, so these two undo each other, so they equal 4. Same thing, when we square the square root of 9, so square root of 9 squared, the square and the square root are inverses, so they cancel each other out. Okay, the same idea can be applied to when we square a square root of -1. Because the square root of -1 is I, so this is like we're squaring an I. So these two will cancel each other out, and we're left with -1. Okay, so that is why I squared equals -1. Okay, now, if none of that made sense, okay, don't worry, you just have to keep in mind that I squared equals -1 because it is bound to show up in the problem. Okay, so let's get going on the problem now that we know why the I squared is -1. Alright, so we have a degree 3 polynomial, which, remember, the degree should always equal the number of zeros. So this means I should have a total of 3 zeros, or roots, or x-intercepts, or solutions, okay? So I should end up with 3 roots. But if you see here, the only roots I've been given is x equals -4 and x equals 4 plus I. Holy hot dog, you're like, Miss Long, what's going on here? I only have 2 roots listed, but I'm supposed to have 3 because it's a degree 3 polynomial. Well, if you think back to the previous slide in the Prezi video from this example problem, we talked about the complex conjugate root theorem, which states that imaginary numbers come in cute little pairs, or what I like to call evil and good twins. So they are twins, but one of them is a good twin and one of them is an evil twin. So imaginary numbers should always come in pairs. So on these types of problems, I am bound to trick you, and I will not give you all the roots, but you have to know, based on the complex conjugates theorem, that it has another pair, x equals 4 minus I. So these come in pairs, and remember the only thing that changes, you guys, is the sign of the imaginary number. This is the only thing that changes. So you see my 4 didn't change. It stayed as a positive 4. But my i's changed signs. Okay, so now we have a total of 3 roots. We have 2 imaginary and 1 real. So yay, we're good to go now. Okay, so now we need to build this thing into standard form, which we start by writing this in factored form. So let's start by writing this bad boy in factored form. Okay, so we have f of x equals, now remember in factored form, we always have parentheses which include x's, and since I have 3 zeros, I'm going to have 3 of these, so I'm just going to prepare myself. I have 3 of these bad boys, bam. Okay, and each of these applies to one of my zeros, and remember, all we do, the shortcut, you guys, is just changing the sign of the 0 and putting it into the parentheses. So the opposite of negative 4 is positive 4. So in factored form, x equals negative 4 becomes x plus 4. Same thing with these, you guys. Don't let it fool you. All we're going to do is change the signs on the 0. So let's look at this one first right here. Okay, so this one started off as a positive 4, but now we'll go to negative 4. And this started off as positive I, but now it is a negative I. Okay, so this one's done. So all we're doing, you guys, is changing the signs. Okay, this one, it started off as a positive 4, so in here it'll become a negative 4. Alright, and then the opposite of negative I will be a positive I. So in here, it'll be a positive I. So all we do to get from our zeros to factored form is change the signs of the zeros. And you change all the signs. Okay, so all we did was change the signs of the zeros. That's it. Change signs of zeros. Or if you want to call them roots, since we call them roots here, that's fine. Whatever floats your boat. Alright, so now you guys, all we're going to be doing is a bunch of distributing, which, when we do this, you must distribute all imaginary parts first. You have to. Okay, and if we do this correctly, all of our i's will disappear, and it's all because of this nifty trick right here, so you'll see why. Okay, so when we do this, we must do the imaginary pieces together. You have to. Okay, so we're going to start by distributing the imaginary factors. Distributing imaginary factors. And after that, we will take into account our real factor, but we have to hold off. Alright, so let's get this distributing show on the road. So, like normal, we start with the first term, multiply to all 3, take the second term, multiply to all 3, and then take the last term and multiply to all 3. So I'm only distributing these 2 right now. So let's see what happens. Okay, so x times x gives me an x squared. Okay, and if you remember, we add exponents when we distribute variables with exponents, which each of these secretly have a 1. So 1 plus 1 gives me 2. Okay, then x times negative 4. Well, I don't really have anything to combine, so it's just negative 4x. Alright, and then x times I. Okay, I'm just going to write ix. Typically, we put the I before the x, but it's not wrong to say xi. Whatever floats your boat. Okay, I'm going to write positive ix. Okay, but you could write xi. And guys, I is not a variable, because if you see here, it equals things that are not variables. Variables constantly change. I actually equals something. I equals the square root of negative 1. Okay, but when we deal with I, we deal with them just like we would a variable. Okay, so think of them when you work with them like they're a variable, but they're secretly not a variable, so be careful. Alright, so our first term's done, so let's move on to the next one. Alright, I'm going to take my 4 and multiply it to all 3. So negative 4 times x, well, there's nothing really to combine, you guys, so it's just negative 4x. If nothing's in common that you guys can multiply, just write them all side by side. So negative 4x. Then negative 4 times negative 4, I can multiply those together. Holy hot dog, right? So negative 4 times negative 4 is a positive 16. And then negative 4 times I, well, I can't really combine anything, so it's just negative 4i. Bam, that one's done so. Alright guys, we got one more to distribute, our nifty I. Okay, so I'm going to take my I and multiply it to all 3. So negative I times x. Okay, I can't combine anything, so it's just negative ix. Negative I times negative 4, and negative times negative positive, so it would be positive 4i. and negative I times positive I. Well, negative times a positive is a negative. I'm sorry, guys, I'm running out of room. Negative. And I times I. Just like when we did x times x here, okay, we add the exponents on variables, which even though I is not a variable, we treat it like one when we solve with it. So this is secretly I to the first, and that's secretly I to the first. So 1 plus 1 gives me I squared. So that is negative I squared. Okay, now, if we did this correctly, when we combine all of our like terms, all the i's should disappear. We're going to be like little math magicians. We're going to make the i's disappear. Are you ready, you guys? I'm totally ready. Let's go. Okay, so x squared, remember we start with our highest exponent, which the highest exponent on our x is x squared, which I don't see any other x squared terms to combine to, so I'm just going to bring that down. So it's x squared. Okay, so that one's done. No like terms. All right, my negative 4x. Let's see if we have any other plain old x terms. I have another negative 4x, but no other, just plain old x terms. So I have negative 4x and negative 4x. Now remember, when you combine like terms, do not touch the variables. That's when the demon cats will get you. So negative 4 minus 4 is negative 8, and I just leave the x alone, negative 8x. Oh, man. All right, so now I'm going to move on to my ix. So I'm looking for another term that contains ix. This one has an I, so it's not quite ix, but this one right here, this negative ix has one, and I don't see any other ix terms, okay? So a positive ix minus an ix, holy hot dog, you guys, they will cancel each other out. So our first set of i's have disappeared. Holy hot dog. Okay, so remember the goal is to make all the i's disappeared. Okay, let's see here, my 16. Let's see if there's anything without a variable that I can combine. Okay, I don't see anything that's just a number without a variable, so I'm going to bring down my 16. That one's donezo. So plus 16. All right, moving on to my negative 4i. I'm going to put it in a triangle. Negative 4i, which I know it's hard to see over here. Okay, I have a negative 4i. Any other terms with just an I? Holy hot dog, one's right here. A positive 4i. So negative 4i plus 4i, oh man, do you guys see that? They cancel each other out. Our i's are disappearing. And guys, this should always happen. When you guys are distributing with the i's, you should always get a positive one and a negative one because they will cancel each other out. Okay, and this last guy, which is hard to see, so I'm going to bring it out here. This last one says negative I squared. Okay, let's see what happens. So we know I squared is negative 1. Okay, so this is like minus I squared, which is negative 1. Okay, so all I've done, you guys, is replace I squared with what it equals. I squared is negative 1. Okay, so now it's minus a negative 1. With a double negative, a minus a negative will turn to a plus 1. So a negative I squared is just secretly a plus 1. So I'm going to add plus 1 onto the end. Oh man, do you guys see that? All of my i's disappeared. That was incredible. Okay, and if you do it correctly, you guys, all the i's should disappear. Okay, and remember, you cannot forget that I squared is negative 1. So minus a negative 1 will be positive 1. Okay, so let's combine like terms, and after we do that, we're going to distribute the x plus 4 to that. Okay, so my only like terms I see are these two. So I'm left with, let's see here, x squared minus 8x, and then 16 plus 1 is plus 17. Alright, so now I'm going to bring down my x plus 4 from up here. We can't forget about it. And all we have to do now is distribute the x plus 4 to all that. Then we're done. Okay, let's get going, you guys. I'm super excited. Which, if you guys think you know how to do this, since we've talked about how to distribute, go ahead and pause the video and distribute and see if you get the right answer in the end. Okay? Alright, let's start with the x. So I'm going to multiply my x to all three. Which secretly, this x has a 1 here. And this x, since it doesn't have an exponent, secretly has a 1, so we'll keep that in mind. So x times x squared, we add the exponents, and 1 plus 2 gives me x to the third. Okay, x times negative 8x, so we multiply the numbers first, which secretly, there's a 1 in front of this x. So 1 times negative 8 is negative 8. And now let's deal with the variables. So 1 plus 1, we add the exponents, and I get x squared. Yay! Alright, then 1x times 17, well, there's nothing really to combine, you guys, so it would just be a positive 17x. Yay, my first one's done. All right, guys, let's tackle the 4. Okay, so now we're doing the 4. 4 times x squared. Okay, there's a 1 in front of my x squared. And 4 times the 1 gives me a 4. And I don't have any x's, so it's just x squared. Okay, 4 times negative 8x. 4 times negative 8 is negative 32. And again, I don't have any x's, so I just bring the x down. Alright, and then 4 times 17, I'm going to have to do that off to the side because I don't know that off the top of my head. Okay, so 4 times 7 is 28, carry the 2, 68. So 4 times 17 will give me a positive 68. Holy hot dog, you guys, we're on to our last step, which is combining like terms. Okay, let's go. Let's combine our like terms, and then we'll be donezo with this. Alright, guys, I'm going to start with my highest exponent, which is x to the 3rd. I don't see any other x to the 3rd, so I'm just going to bring that on down. Next, I'm moving on to my x squared term, which I have one there and have one there. Okay, remember, we cannot touch the exponents. Don't touch them. So I'm just going to go ahead and write x squared before I'm tempted to do anything. And then I just combine my coefficients, or the numbers in front of the x's. So negative 8 plus 4 is negative 4. Nice. Alright, my next highest exponent is x to the 1st, which these are secretly x to the 1st. Okay, so I have a 17x and a negative 32x, which I'm going to bring down my x's before I touch it. And then I just combine my 17 and my negative 32, which a negative 32 and a 17, that's going to give me, I'm pretty sure, a negative 15. Yes. So it'd be negative 15x. And then lastly, I just have the number without the variable, my 68, and it doesn't have anything else to combine to, so I'm just going to bring that bad boy on down. And bam, we have gotten this thing in standard form. We started with our roots, and we have gotten it to standard form. Wasn't that insane, you guys? That was like the ultimate standard form, or 0 to standard form party, I guess you would say. Those are also really fun parties to throw. Starting with zeros and ending up with standard form. Nice job, you guys. I had an awesome time.